Welcome to Zero Knowledge. I'm your host, Anna Rose. In this podcast, we will be exploring the latest in zero-knowledge research and the decentralized web, as well as new paradigms that promise to change the way we interact and transact online. This week, I catch up with Ye and Sandy from Scroll. We check back in on the ZKEVM L2 project and find out how it's developed over the last year. We talk about the founding of a fully remote organization, the technical evolution of the project, the ecosystem, and more. A quick disclosure, I am, through the ZK Validator, an investor in the project, and it's been fun to learn about their progress. Now, before we kick off, I do want to direct you to the ZK Jobs board. There you'll find jobs from top teams working in ZK. So if you're looking for your next job opportunity, be sure to check it out. And if you're a team looking to find great talent, be sure to add your jobs to the jobs board as well. I've added the link in the show notes. Now, Tanya will share a little bit about this week's sponsor.
Ever feel like developing zero-knowledge proofs is a daunting task? Well, the team at RISC Zero is here to remind you that it doesn't have to be that way. Their out-of-the-box tooling allows developers to access the magic of ZKProofs from any chain without needing to learn custom languages or build custom ZK circuits. Bonsai, RISC Zero's most anticipated product, is a proving marketplace that enables any protocol or application to leverage fast ZKProofs in languages like Rust, Go, and C++. Visit r0.link/ZK podcast to learn more and sign up for the Bonsai waitlist. You can also find the link in our show notes. And now, here's our episode.
So today I'm here with two of the co-founders of Scroll, Ye and Sandy. Welcome to the show.
Thanks for having us, Anna. Very excited to be here.
Yes, thanks for having us.
Ye, you were on last year in, I think, June 2022. We did an interview with yourself and your third co-founder, Hai-Chen. So that was like our introduction to the project on the show. And yeah, something that I'd like to do with this episode is definitely do a catch-up. Before we do that, though, Ye, why don't you quickly introduce yourself?
Sure. Hi, everyone. My name is Ye. I'm the co-founder of Scroll. I work on ZK research, hardware acceleration for zero proof, some algorithm side, and some application side.
Nice. And Sandy, this is the first time you're on the show. So why don't you tell us a little bit about yourself? What got you interested in this space, and kind of where was your sort of journey to Scroll? Where did that start?
Yeah, no, thanks for having me. So my crypto journey started a long time ago, around 2013 and 14. That's when I first read the Bitcoin white paper and, had that aha moment and just been kind of researching and dabbling and socializing in the space. My first kind of full-time crypto job started in about 2017 when I became a crypto investor full-time. And the journey for Scroll started when I was getting deeper and deeper into protocol level research. And it became very clear to me at the time that Ethereum was gaining traction, both as a protocol and also on the social layer. There were just the amount of talent and creativity surrounding the main protocol was astonishing. And I kind of came to this realization that this was the future of the crypto space. And I wanted to see whether there are any kind of major open problems I could contribute to. And that's when I met Ye and Hai-Chen. We met online, and we didn't actually meet in person for the entire first year of working together on Scroll.
Whoa.
And
cool.
Yeah.
But you were not anons. You knew like you were yourselves, I guess.
Yes.
Okay,
so,
okay.
Ye couldn't have been an anon because when we met, he had a paper pending publication on prover acceleration. And that's how we originally found him. And Hai-Chen was working at Amazon at the time, as a system architect, and he worked on a lot of the stuff that we're currently using for Scroll.
This is actually interesting. The co-founding online. How, where were you chatting? How would you have met and almost vetted each other in just online?
Yeah, I think there's with every kind of meeting, there's always a little bit of serendipity involved. How does anyone meet anyone in this day and age? So it starts with an online conversation, and then there are some like offline connectivities and personal relationships. And so initially, I was connected to Ye through one of his kind of one of our mutual friends, and started talking online for a really long time, and then decided to kind of go for it, what was the Scroll project at the time, like almost like very quickly, but it was a research project, and and then just it just kind of continued to snowball from there, really.
So I really liked that idea of like founding a company purely online where you don't, I guess it's like, what year was this that you were starting to look at this project?
It was during the peak of COVID. So it was about 2021. And I think it's the same process for most of the people on the team. I think there are at least half the people on the team whom none of the co-founders have met in person in the first, and it's still very common for us to not meet someone in person until, 3 or 6 months after they've been working with us. We're very decentralized as a result of this kind of type of origin. And we have members from every continent, apart from the Antarctica. And so spanning over... Yet, we'll see. Very keen on, taking over that piece of ice. But yes, so essentially, I think that's part of our founding DNA, and that's resulted to, Scroll core contributors being, all over the world, really.
Cool. And you sort of mentioned that you were excited about Ethereum. This is like the project is kind of coming out of the Ethereum ecosystem, but like had there already been proposals for ZK EVMs at the time, or things like Scroll that you were playing on or kind of being inspired by?
I can talk about it from my perspective. I think there's already been a few L2s that are ongoing. When we started, we were inspired by a lot of years' research and a lot of the research that were coming out of academia at the time. And we thought there was something that we could offer, both by means of outsourcing proofs offline and also this way of organizing a completely open source kind of effort. So maybe Ye can talk about his experience as well.
Yeah. I think by the time when we started, as Sandy mentioned, there are several layer 2 efforts. But I think none of them are really building a like EVM bytecode level ZK EVM. So some, I think the closest one is building a language compatible, but I think we are targeting a deeper level of compatibility, which means we will suffer from a larger proving overhead and like much more engineering work. And we kind of make sure that we can, through hardware acceleration, through this crypto, like advanced crypto algorithms, can make the efficiency become like order of magnitude like better than before. So that's why we start this and with the deepest level of compatibility.
Had things like Jordi and the Hermes ZK EVM proposal already come out when you guys started? Or was it happening at the same time? Like, I know that there was like the sort of, I don't know if Starkware proposed something, but it was like, I know ZK Sync had proposed something, but there was all these different types of ZK EVMs. But I do wonder, was there anything like yours? Or was your research kind of like really this new direction?
Yeah, that's a great question. So I think the very original story that we start with something, our own version of like how we build a virtual machine, maybe ZK EVM or like ZK virtual machine. We can make this really efficient through hardware. So that's our initial version. And then like I talked with Barry Whitehead at EVM Foundation, and he's thinking of exactly the same idea of building ZK EVM for EVM layer 1. And I think our idea overlap a lot for like why we think supporting a virtual machine is possible. And then so our like collaboration start very organically, like with Barry and with EVM Foundation. And I think there are some nice ideas for using lookup tables to handle the virtual machine memory part. of the ZKEVM. I think the same idea also inspired Jordi to start ZKEVM. So I think
that's kind of how it comes from. Okay.
Yes, exactly.
Same original source, but like
Yes.
kind of happening at the same time.
Yes, exactly.
Got it. Cool. Yeah, actually, I should, we will add a link to the previous episode. What I wanted to actually do, at least with the first part of this, was do a little bit of a check-in on some of the decisions that were kind of being discussed back then. Like, I wasn't sure if those were like finalized or if they were like still in the works or if things had maybe changed. So just a quick throwback. A year ago, when we talked about kind of what was the underlying ZK stuff, it was like Planckish arithmetization and Halo 2. Is that still what Scroll is based on? Or has it brought in, I don't know, some like new techniques or other proving systems?
Yeah, I think the tech stack is still remain the same. Like we are still using Planckish for writing our circuits and using KZG at the backend, using Halo 2 to write our circuits. But huge improvement have been made on the completeness, performance, and the robustness. So for example, on the circuit side, I think when we talk, we implement the majority of the circuits, but there will still be some circuit left. And by now, we have already implemented all the opcodes, all the error cases, and they have already been sent to the auditors to audit. And on the prover side, I think we make extremely fast GPU implementation to make prover really fast. And also we publish our paper. So I think by the time we talk, we only have one paper talking about how you use FPGA and ASIC to make prover faster. Now we have published another paper talking about how you use GPU to make prover faster. And also we done a bunch of ZK research, reducing the memory consumption, and also the recursive cost. So basically, I think the day one when we are running our ZKEVM, a full version, we require like 1 terabyte of CPU memory to run such a large, gigantic circuit. But now we reduce that to only like hundreds of gigabytes. And we are still keep improving on that. And as for the toolings, I think we are using some derivative of Halo 2, which is called Halo 2 CE. It's CE referred to Community Edition, so it's a derivative version from the cache branch. Because this is we make many changes to this library, and also we want to, because it aligns with our philosophy to always develop with the community and sharing all this like proving stack and all the toolings with the community. So it's a community effort to own this proving stack. And we are leading some discussion to add more components into this library. I think a lot of projects are actually reusing the same proving stack. People are contributing to that. Even for some new like optimization from Fry, it's totally different, but people are still implementing like Goldilocks field, Fry gadgets to this community owned library. So yeah, that's like aligned with our philosophy a lot. That's on the ZK side.
Cool. I want to check the naming really quickly. Halo 2 CE. Yes. Is that what you said?
Yes.
What does that stand for? Community
Edition.
Okay.
Yes.
And this is this sort of like, I mean, is this the work that like PSE, Privacy and Scaling Explorations group from the EF and Xerox PARC had been kind of like championing? Or is there one track? Is it yours? Like, did it also branch out into other ones?
So originally, we are using a fork of Halo 2, and the upstream is in the like PSE's GitHub library. And we just changed the polynomial commitment part from the inner product argument to KZG. But then we want to make this more modular and shared by even more projects. So there depends a separate organization called Halo 2 CE, and there will be more projects contributing to this library. Like for example, Axum and some other projects are contributing to this. And we are leading some kind of more open discussions about how we can improve this library. So initially it starts with, we want to build the ZKEVM, we want to use KZG, so we use this fork. And then we want to make this more modular and more people can use that. So that's how it's branched out.
How do you sort of split your time in that regard? Like as a development, like you're developing like something, you have a goal, but at the same time, there's like a lot of research and work that could potentially contribute to other projects. Like, would you say you as a research team are like super focused just on the things that you need, or do you think it's a little bit more fluid? It sounds like you're also contributing just kind of more generally.
Yeah, I think our philosophy is like trying to support open source and more community driven and shared like tooling stack. So we are happy to kind of either contribute to this like shared infrastructure, and even upstream to the Halo 2 upstream, which is initially developed by Zcash. So yeah, we definitely like spend a lot of effort on like how we can like maximum like different projects, like, proof of compatibility, and also like, because it also enhance our security, right? Because if many people are like reusing the same proving stack, like there will be more people, more eyes looking into your code base and review, and you also get a share, like, yeah. So that's our philosophy.
That's actually an interesting incentive there. The idea that like you may actually just want to make something more general to be used by more people,
yes,
so that people try to break it early, right?
Exactly.
I feel like there's been some chats actually in the ZK channels right now about like security of some of the systems that a lot of things are being built on. And I do think if you can have more eyes on it, obviously that's a really good way to like hopefully spot bugs early. Yes. You talked a little bit about the GPU implementation. This is for the verifier or the prover?
Oh, this is for the prover, like how you can make prover generate proof faster.
And when you talk about a GPU implementation, is this different from the rest of your tech stack? Is this like some like lower level, like how to better interact with a GPU? And I guess the second question to this is like, do most rollups and ZK EVM teams need to do that? Because I don't think I've really heard about like the teams themselves working on the hardware.
So you can imagine that, when you are running your algorithm initially on CPU, for example, it takes like 1 hour to generate the proof, and you think it's too slow, and you want to utilize the parallelism inside your proving algorithm. So you incorporate the GPU into your like CPU device, and it's just connected, and then you will outsource some very expensive computation to the GPU. And GPU is very good for doing some parallelization work. And it can do that very well. And the most computational heavy part inside the prover is parallelizable. So it's very easy to accelerate that on GPU. It can make, become like 10 times faster. So you are basically, the high level idea is that you move the most computational intensive part to GPU, and the GPU can make that faster. Yeah.
That's what you're doing, like on the software side. You've made the decision what needs to be used by GPU and what isn't.
Exactly.
But are you actually dealing with like how the GPU processes it as well?
Yes. We also need to implement like how you kind of run this on GPU. You need to design the kernel, implement using CUDA. So yeah.
Oh, wow. And yeah, then I guess the second part of that question is that something that a lot of ZK VM teams need to be doing? Or is it because you had this background in hardware that we talked about in the last episode that you were like, oh, we're going to also do this hardware part?
Yeah, I think for GPU, it can make all the ZKVM become faster. But I think currently, from what I know, most ZKVM teams are using GPUs, but some that need, because it depends on like your proving algorithm. If you heavily rely on some kind of iterate curve-based operation, which can be massively parallelizable and can be accelerated really fast on GPU. But if you are relying on more like smaller field hash function, then maybe you can run that on CPU efficiently. But I think overall, if you have GPU, it can always be faster in most cases.
Okay. So I guess most of the ZK VM teams, if not building it themselves, will be using some sort of open source version of this because it's kind of an inevitable thing. Do you feel like this is just part of the engineering challenge in general? Like this is where you can get some improvements, so you will inevitably want to go for it?
Yeah, I think it's definitely part of the engineering effort, but also like one direction we are working on this, which is also aligned with our like decentralization philosophy, that we want to reduce the requirement for for example, the memory requirement for GPU, and we are trying to lower that requirement. For example, like maybe miners, because people believe that you will move from proof of work, you will have a bunch of GPUs, and one direction might be how we can adapt our algorithm and generalize this algorithm a bit and to adapt to other cheaper GPUs so they can still reuse their machines to run our proving algorithm.
Like I've done a few episodes recently on hardware, kind of looking through the lens of the Z-Prize efforts. Do you expect sort of just like a standard for how GPUs and ZKPs are going to be used? Or do you think that there's still a lot of room to like develop unique solutions there?
Yeah, that's a great question. So it depends on the algorithm. I think eventually it will become a problem which involves software and hardware co-design. So for example, recently people are really crazy about Nova and you might need some special components for making Nova faster. So because the proving algorithm keep evolving, so it's very hard to say that this is your final version of GPU. But I think most algorithms are reusing almost the same like primitives like FFT, multi-exponentiation, and some vector level computation, maybe some hash function. So I think the large modules are fixed. But if you really want good performance, you need to tune like the workflow and for your proof system. So I think that haven't been fixed. It depends on your software stack. So eventually it will become, I think, a software and a hardware co-design problem.
But then do you think it won't be GPU and you'll just like move towards FPGA and then ASIC? Like just if it becomes a little bit more,
Yeah.
I think if even you can like figure out which things you need to focus on, could you start to go in that direction?
Yeah, definitely. But I think in our current version, we are still more bullish on like using GPU for short term, because firstly, like people have more like general purpose GPUs in-house, and they can run prover without buying like expensive FPGA and ASIC. And also one interesting observation from our conversation with different hardware companies that single board FPGA is very hard to beat GPU performance. You have to connect many FPGA boards together to beat one GPU performance. And ASIC might be better. So long term, it might be ASIC. If you are like kind of having one protocol become dominant ZK protocol, and there are ASIC for this protocol, then that might be a best combination. But now, like because the algorithm hasn't been fixed and the GPU is still general purpose, people can buy that. And so I think short term we are still more. Yeah.
Cool. Sandy, I want to sort of ask you a little bit about the kind of ecosystem and like Scroll world since, I mean, you weren't on the last episode, but like since maybe you started. When you first founded the company, was it just the three of you or was there already a team? And like, how has kind of the world around Scroll evolved?
I would say day one, it was just the three of us. And but the snowball effect happened very quickly. And I think the first turning point was when, I think as Ye mentioned that when PSC team, when Barry started supporting the project, and we very much became a global community effort overnight. And having that, very strong partnership meant that we're able to scale and gather resources in a way that wouldn't be possible otherwise. And then I think the second turning point was when we started having an MVP and when our vision started become clearer. And the vision was to build a product that mirrors the developer experience on Ethereum Layer 1 as much as technically feasible. And once that positioning is clear, it started attracting more and more talents who are like-minded and who also sees the same vision. I think the wider vision is that we're in the first of 9 innings of the global, if we think blockchain will be the value layer of the internet, then we're in the first of 9 innings. And if we're able to kind of have the leg up of inheriting all the tooling and all the great things that have been built on Ethereum over the last few years, then we're off to a good start, but it's still a start. So I think once that vision is well articulated and shared within the wider Ethereum researcher and developer community, we started to see a effect where people are applying to Scroll and people are reaching out to us on Twitter. And I think from early on, we had this policy to hire the best talent globally. So you're not restricted by where you live and you're not restricted by, your identity. And obviously we do KYC on anyone that joins us full time, but essentially we started building this culture of like hiring straight from Twitter and hiring straight from Discord.
Whoa.
And that was very energizing for a lot of our community members who can see people who actively contributed to open source research. So this is kind of, I think one thing I often explain to Web2 people how Scroll has grown so quickly in head of headcount is that, the great companies companies from 10 years ago, all built from a very kind of employee corporate structure. But now we're very much a kind of, we need to articulate our vision and set up in a way that anyone can see what we're building kind of week to week, and anyone can catch up and contribute as they wish. And if someone does have value add to the process, then we'll bring them onto the core team and train them and equip them with whatever they need to like succeed in this endeavor. So I think that's how we quickly scaled, and we have a 40 plus engineering team now, and I think it's very difficult to find ZK engineers, and especially ones with prior experience. And I think that's very much due to one is the vision and the architecture that has so well articulated. Another thing goes to kind of Haichen's ability to run an agile process, run a global development engineering team, and making sure everyone is well supported to work on this really.
Yeah. How do you do that? Like, especially if you're, because you're more, I think of you a little bit more on the research side.
Yes.
Is Haichen more on the engineering side?
Yes, exactly. Haichen is leading our engineering team, and I'm more on the research side, both ZK and protocol research.
If you're like getting kind of contributors in, are you growing in a very like flat way, or is it sort of like you're starting to create these structures? Yeah, I'm just curious how you do it. Because like, I guess, how big were you last year?
I think last year when we talk, it's around like, it's still like 30 or something, researcher or engineer, but it's
okay,
like...
you've grown by 10. Okay, so it's not too crazy.
Yeah, but that's only on the technical.
But maybe just from that starting point to that. Yeah, like from that starting point of just like a very small team to the 30 or to the 40. Actually, I think there's a lot of teams out there who could really, like, who potentially really want to know how you did that, because I think there's sometimes, it's hard to maybe create those structures on the fly as you're going really quickly.
We have lots of mini teams. It's not like, there's the ZK EVM team that collaborates with the PSC very closely. And then there's the infra team. And then the hardware team is part of the infra team that talks very closely to them. And we try not to have teams that are across more than 2 time zones in order to make sure everyone has a good work-life balance. And
interesting.
We're also starting to have some kind of regional kind of city offices. So we don't have any city where there are more than 3 scrollers right now, but we have 3 in New York and we have 3 in San Francisco. So we're in the process of setting up like mini kind of co-work offices, and we're hoping, at least the New York one has proven to be a reasonable kind of hub for ZK researchers to stop by and hang out. And we're hoping to have more of these types of kind of pop-up offices everywhere.
Nice. On that research front that you're kind of more in, would you say, like, you have your inner team, the folks that are on the Scroll team, but I feel like you must, I've seen you actually collaborating with lots of different groups. How does that all work? And like, I'm kind of curious, like, how much of the new research are you letting in? Like, is there a point where you have to kind of cap it and say, like, we can't do any more changes? We can't add any more of the like cool new stuff? Or do you feel like it's still very, very fluid?
Yeah, that's a great question.
I feel like there was 2 questions in there. Sorry. There was like, what's it like working with other researchers outside and inside? And then there's, how are you incorporating new research?
Yeah, that makes sense. Yeah, so the way like we are like operating on the research team is that we define some larger scopes. For example, like there is ZK research working on like more efficient prover, more efficient aggregation. And we are definitely looking into like new constructions. Like recently people get Nova built, and thinking about how we can move some primitives to Nova and integrate in our current system. So that's on the ZK research side. On the protocol research side, we are looking to, for example, decentralization of prover and sequencer, the mechanism design between, and how we handle MEV, and also like how we use multi-prover to include the security, and maybe eventually when we when EVM move to like dank sharding, we will be bottlenecked by this execution. We are looking into EVM parallelization and more efficient client implementation. So there are actually, and also like some resource pricing for layer 2. So there are some large scopes there. We are always looking into what's a problem we are going to solve in 1 year or 2 years. So we are actively working on that. But, you also mentioned there is a product going on. There is like, you always need to launch some stable version. You need audit, you need stable. So we will have multiple versions. And in this like recent version, in a stable branch, which engineers are mostly working on, and they are looking to more stabilize and battle tested, well audited as our version 1. And then in the next version, we'll think about how we can like kind of merge those different research results into those kind of our current version, and how they can integrate with our system, and what they kind of change a part we need to audit, and how we kind of coordinate across different teams. So it's more like, even for Ethereum, it has EIPs, it has like small changes to make that works and in the next version. So we will also have versioning. And so it's like version 1, it will be very stable, sound, and complete ZKEVM. But the next version might be like, we make some tricks, we change the proving algorithm a little bit, and then like make that even faster. So yeah.
Cool. I want to talk about, so this sort of speaks also to the sharing of research, but like the competitive landscape. Last summer I think at ETHCC, there was like all the announcements of ZKEVMs, right? It was like the week of ZKEVMs. And I remember that like at least the Scroll ZKEVM announcement, I think you kind of put yourselves on the stage with that. I think a lot of people didn't really know about what you were doing. And I feel like this was kind of like an opener. How has that changed? Tell me a little bit about, what you're seeing on the competitive landscape.
I think I would probably challenge the framing that all L2s are competing in some fundamental sense. Okay. I don't think this is a productive way to think about the space. We were never thinking about the competition when we did the initial testnet launch, and we're not thinking about it now. What has changed is that we're more and more confident with our testnet results. Our testnet with proofs have been running for a few months, and we can talk more about the roadmap and what we've learned since the Paris announcement. But taking a step back, I think that the fundamental view is that there are still very few users in the space. So there are like 2.5 billion monthly active users on Instagram, for example, and that's just one single app. And there are 5 billion active internet users in the world. So I think crypto as a whole probably has about like 1 million active users. And even that's being very generous with, what we believe to be users in terms of definition. So if we believe in a future that has potentially 1,000x users, then does it really make sense to think about like competition endlessly? I think we're all just kind of in the first of 9 innings. And I think the real landscape is that the space to be gained is so large, and the design space for infrastructure to tackle is also incredibly large. Like the feedback we've had are from a very, very small subset of the internet population. And whether that's real or true, and whether that's like enough for like a real world testing, that's still like can be somewhat called into question. So I think, and also another thing that's changing that's not related to the L2 space in particular, but in the wider internet space, it's just that, the definition of user and developer have been framed very differently so far in the crypto teapot. In the crypto bubble, these two categories are framed very differently. But in the real world, every user in the world will eventually become a developer because of natural language that can be used to produce functional, programmatic instructions. And so the line between these two are blurring. And the number of active developers, like dApps and infras and so on, is about 100K in the space. And once again, that can easily double or 10x because of this particular change that's parallel to the crypto universe. And so, we don't believe we're in competition with anyone. I think the landscape is still evolving very rapidly. And we care about our users, and we're building, and we're set up for longevity and for impact. And we actually pay very little attention to what the next L2 is doing. But overall, I think having more participants in the space is very bullish for Ethereum, and it allows for more experimentation. And that's a good lesson for all of us. And I think one thing that, even if there are like hundreds of roll-ups, when we go on the call again, is that I think amongst all the roll-ups, I think legitimacy is the only thing that truly matters. When you're thinking about trusting your life savings or trusting your assets or value to a network at the end of the day, I think the sense of like security and trust and legitimacy, although these are like very ambiguous terms, but what you trust a network to kind of put your life savings to, it's a very nuanced and multifaceted thing. It has a lot to do with the development strategy and, the trust you can build and maintain and the systematic things you set up. And I think it ties a lot into the core values like, decentralization, security, and like well thought out design principles, etc. So I think we're in the process of figuring out like what that is exactly.
I really like what you just said and the sort of focus more on the collaborative part or growing the pie instead of trying to split the pie. I still think in the space there is a competitive nature. Some teams, I think, are already at least competing on the marketing front. Do you see any benefit in that? Like it sounds like your strategy is to definitely focus on collaboration, but like, do you think it also brings a bit of attention that might actually be good?
I think any attention to the L2 space is net good for the world as a whole. I think the fact that we're seeing like centralized exchanges now issuing L2s rather than their own L1s is a move in the positive direction. It's a sign of the wider crypto ecosystem adapting to the mindset that L2 is the way forward, is the way for scaling. And so anything that moves people away from the Alt1 rotation trap, I think is a good step forward. And I think any kind of marketing in that sense is positive.
That's interesting. I have a question. Like, I feel like the Scroll project is born so deeply and within Ethereum, but have you as a team paid any attention to Cosmos or like the Polkadot models, like any of these other sort of like networks where they have the connectivity through different ways? I mean, I know the project is very Ethereum. Is there any cross-pollination of like ideas between those ecosystems and Ethereum?
I would say I learned a lot from the Polkadot ecosystem in the sense that I think there is a culture of putting developer first. And I think that's also part of the Ethereum culture as well. And the things that made Polkadot so successful, we're also keen to kind of learn from those lessons and do the same for Scroll, just putting developer first and being steadfast and being a kind of friend on the developer to founder journey as well. From the Polkadot ecosystem, I think there's also a lot to learn. I think the lesson there is that certain projects have specific needs, and sometimes they would like to share economics at the protocol level. And I think these narratives are yet to be played out. But one thing that keeps me building in the Ethereum ecosystem is that if I have to spend a day figuring out how to bridge stablecoins into any new L1s, then I'm going to give up. And I think that applies to both of these things, both of these ecosystems. That's my test on how long or whether I should kind of consider seriously like spending a significant amount of time or resources on any ecosystem. So that ties into the second point, I think, it's a value that we try to kind of prioritize at Scroll, which is just putting developer and also user experience first and making it as accessible as possible. So, hopefully the process of bridging stablecoins onto Scroll will be, a lot easier than you would for Polkadot and Cosmos.
I kind of want to ask a bit about how you envision the Scroll roll-up looking. Do you actually imagine it as a single instantiation, or do you almost like, could it be that there's like multiples of it for different uses? I don't know if that's like a roadmap thing or if that's even something that's been thought of. Like currently, are you just thinking about it as like a single version that like, that's where you want all of the dApps to live?
Okay, I can talk a little bit more from the technical perspective. So I think we start with solving the problem of Ethereum, because Ethereum is congested, expensive. So that's why we want to build a platform that can solve this problem. All the transactions, all the applications can deploy here and cheaper, faster throughput, and enhance the security. So that's the starting point. And I believe that so imagine that in 5 years, because layer 1 will be even more expensive, and all the interactions with the ECM application will be moved to layer 2. And because layer 2 as a network has this strong network effect for application have this dependency and how many users you have, so I think there will be like very few layer 2s who will be general purpose and relying on ECM directly. And then there might be some other chances to kind of build their protocols on top of layer 2, either as layer 3 or some more creative form. We don't commit to any future because, it's like even layer 3 is a new concept proposed by people. We are not making like any choice among like, we have to think future is like one layer 2, multiple layer 3s, but we are thinking something like more creative. Maybe there are some other form like, can also extend our layer 2. But we believe that as a layer 2, we should, firstly inherit all the kind of, not only from the technical perspective, we inherit the security, we are cheaper with a higher throughput, but we also want to inherit this kind of legitimacy, this branding of ECM, because all the users will interact through layer 2. We want to kind of keep this spirit to be the same. And then like more people can build more creative stuff on top of Scroll, like cheaper miner, but still like different teams are betting on different future. But we are still like looking towards because also like again like many futures are like people are talking about this future, but they are hand waving about the technical details. We are thinking more in the long term that we propose something which is technically feasible, and also it's good for building like the entire like it's almost like an entire country, and then like people can build their own like island or cities on top of Scroll.
On top of it.
So yeah.
But you don't imagine deploying 2 scrolls. That was kind of what I'm wondering. Is like just generally like once you build the stack, you could, right? Like you have all the software.
Yeah.
But I guess there's no real use case for that right now.
People can still fork our code base, fork ZKVM and launch their new ZK rollup. But again, like it back to the question, like when Sandy mentioned, when there are hundreds of rollup, like including all the forks and legitimacy and the trust you build for certain layer 2 will be, the biggest issue, like biggest reason why people choose you. And then there will be a like massive network effect why people will choose build on you. And also because we are building a ZK EVM, which is a general purpose ZK rollup platform. So we are not targeting at specific use cases. So all the applications will deploy on us. And also like, especially specifically for some DeFi, like they need this composability. So which means it's hard to kind of launch many app chains and having the same composability, same UI and UX for users. So that's why we believe that there will be some dominant layer 2s with strong network effect. And then like, even if other people are forking, they need to have their own feature, maybe tailored for specific applications. But we believe that's part of like, Scroll family instead of something in parallel.
Got it. And that's actually sort of what I'm trying to sort of envision. This is like a very general, like roll up future kind of vision, but like, do you sort of picture these like large generalized L2s being few and far between, but then smaller L2s still attached potentially to the main chain, the L1, that are specialized? And then obviously on these larger L2s, you could also have that L3 in certain cases. But I wonder, like, is that sort of what you envision? Like, have people talked about that?
I think all the people are envision like a similar future, either like multiple layer 2, multiple layer 3, like build on top of each other. But again, like, I think our point is that we are still doing more technical assessment for how practical this is and what's the interoperability, for example, between layer 3s and what's the benefits you get from there. And so we think there might even be some more creative format, even like not layer 3, not layer 2, but maybe some more creative thing like in between to build a future. I think no one can is 100% that the future is look like this, but there are like some reasoning behind like having layer 3s on top of layer 2. For example, like imagine that if all the activity are happening on layer 3, people need to deposit and withdraw. They also want to do this cheaply on their base chain, right? If you do this, for example, if you build some special application as a layer 2, and then like your deposit and withdraw is also, unless you have some way to have this kind of user want to put all their money on your platform. So unless you are very attractive that user want to kind of deposit and withdraw very frequently, then like most application will do this still And if you are building a layer 2, then this will be very expensive. And if you are layer 2, then it's
you're saying if you build on
expensive.
L1, it would be very expensive, right? Oh,
Yes,
so you just said
and
L2.
if you are building your layer 3 on layer 2, then your deposit and withdrawal will become much more cheaper. And also because people have the reason to put their money on layer 2. And then but if for your own application, people are just interacting and playing with that for a while, and then they still need to do this interaction with the base chain very frequently, which will become problematic. Yeah, and also I think if you imagine the future to be all the applications on layer 2, then it's beneficial for layer 3 to launch on layer 2 to kind of directly get the users, get the liquidities on layer 2, and build some featured applications. Yeah, there are already been some experimental layer 3s deploying on Scroll, and also that's what we plan to support, adding more verification algorithm, supporting that on our layer 2 to support more creative experiments.
Do you ever look into things like eigenlayer or sort of the DA levels? Is that something, because that is sort of being built for the EVM, the L2s, right? In a way?
Yeah. In a way that technically, if you use other DA solutions, it can be cheaper in some sense. But they are still...
Oh, by the way, by DA, we mean data availability. Should have said data availability, DA. Yeah.
Okay, data availability. Yeah. Thanks for explanation. Okay. So I think for us, for our own purpose, because we believe that as a layer 2 platform, we want to inherit all the security properties of EVM. So that's why we decided to post our data onto layer 1 to maintain the same security. Because whatever the DA solution you are using, there will always be trade-off. For example, if you become a validator, and you restake across different platforms, there might be some risk for kind of, if one platform has some problem, then it brings some systematic security issues. So I think for us, we just want to stick to this very traditional model to inherit all the security models and become by definition a roll-up, because there are some interesting debates also around what's your definition for a roll-up. And I think a more popular opinion is that you post your data onto EVM and let EVM decide which is your canonic chain. And that's the reason why I believe posting this data on chain will always bring you a highly security. And maybe for some other applications, depending on Scroll, they can decide by their own community, either they want to have their own DA solution or running their own sequencer. So that's another reason why people want to launch their layer 3. They want to have some kind of, governance over this process. Yeah.
As you describe all this, though, all I can think of is the bridging between the different L2s. And I think when we were first talking about this, I always imagined almost like a one-to-one, these little bridges. But I feel like there are newer solutions now kind of emerging. Can you talk a little bit about that? How you picture, do you still imagine people actually using the L1 as the transaction layer, or do you actually imagine the L2s kind of speaking more to each other?
Yeah, I expect layer 2 speaking to each other, but I think it's almost the same hard to build bridges between different layer 1s, even if you are sharing the same. I think people have the impression that if you are building a bridge between two different layer 1s, that's one kind of bridge. And if you are building bridges between if you are sharing one layer 1, you build multiple layer 2s, and layer 2's bridging might be easier. But in fact, it's still very hard to kind of bridge between layer 2s. I think so. I think my prediction is that because all the activities will move to layer 2. So that's the reason why I think bridgings between layer 2 will be more frequent, but it's still almost the same hard to build bridges between different layer 2, because still, even if you there are some ideas where, because all your state root will be posted on the same layer 1, there might be some way that you can read data from state root and prove that, but it still, either takes a longer time to generate proof, or you don't have very great kind of atomic interoperability. So I think it's still hard. I think it's still a unexplored space, and so people are still doing more experimentation there.
What about bridging that isn't token bridging, but rather just message passing? Because I know there's some really interesting things around that.
Yeah, I think my own prediction for this is that because arbitrary messaging is even harder than just token bridging because
Really?
because you can like make your kind of token transfer
Because there's more
because
things.
you can make your token transfer become part of your arbitrary message, right? Like if you want to kind of send some token to another layer 2, it's kind of part of your message, right? So I think it's even harder, especially if it's like a smart contract function call or whatever. So yeah.
Oh, that's interesting. I want to talk a little bit about, I kind of want to revisit the ecosystem topic and, the connection now that Scroll is a standalone project with a team. It was grown out of the PSC group, or like it was, connected to the Ethereum Foundation and stuff like that. But what is the rapport? What's the relationship? Like, does Ethereum support anything in Scroll? And then I also kind of want to ask about ZeroXPark, if there's anything, because I know that like, at least in terms of the libraries, there's a lot of overlap. Are there any sort of like, clear collaborations between those three groups, yourselves and PSC and ZeroXPark?
Yeah, I think, because part of our philosophy is like developing the open source way, and we are really grateful for all the contributions from this community. And there are several like open source collaborators we have been working with, as you mentioned, like there's the PSC team, and we have been co-building the ZKVM over the same code base for nearly 2 years. And we derive into like our layer 2 ZKVM, but we are also helping them to build a Ethereum equivalent ZKVM for Ethereum. So that's the relationship is pure like we are in the same community, pushing the same dream.
Yeah.
And so that's the relationship, and we start together, and we have been like long-term collaboration. And I think for ZeroXPark, I think we hosted many workshops around our toolings. So that's why you see a lot of overlaps and why people are reusing the same tooling.
Yeah.
Because we have done a lot of like workshops with teaching like people how to write Halo 2 circuits since early last year. And also we give lectures about like proving cost and our ZKVM circularization. So it has some impact for, the candidates there, like why they choose this library. And I think education is definitely super important for like why people are using this tooling instead of, because you just get more tutorials and more help like when you bootstrap this.
Yes.
I think our relationship is more like, we believe in the same goal, we are value aligned, and we believe in this open source. And so that's why we came together and sharing some educational resources and discuss. And more recently, there will be a lot of discussions about new proving systems like folding, supernova, paranova, hypernova. Yes. Like, we find something cool together, and then we are excited to see like how far it can go. And we also want to support this ecosystem and this community grow as much as we can, like how people are like using this and how it can integrate into our system.
I personally just really love watching and seeing how these ideas are developed, like how like some very compelling proving system or new research is introduced, and then you see a tutorial or someone wants to teach about it. And I think the Nova example is a great one because, I mean, it was almost a year ago that Justin Drake was like, he wanted to do a whiteboard session about Nova. And I didn't know what that was at all. But now you can see, like, at least in the sort of PSC, ZeroXPark, and you guys, like, you see this sort of like, there's a lot of people who are really excited about it. And now you see that also spreading too. I know Ariel got Nova pilled recently. And like, there's like there's people who are getting introduced to these ideas. And then it's interesting to watch that happen and the material that gets created. But it's also sort of interesting to see, like, why are there proving systems that also might be really compelling aren't quite getting the mind share? And like, as there are more groups popping up, because I don't know if you've noticed, but like there's new ZK everything every time. Like every week there's like a new ZK newsletter, a new ZK event, and that's awesome. And I do wonder if we're going to see sort of these like areas of research, these sort of like clusters almost of shared research. I think this is one, and it's really fascinating and kind of amazing to see it in action. That was my little community take there.
Yes. I think part of our philosophy is like, we want to geographically extend this ZK community to everywhere. I think Sandy have more to say about like how we build this kind of ZK community around every corner of the world and how we spread this kind of information, because through education and through some other local events.
Yeah, no, I was going to add to that and say, I think, any team essentially that is aligned with the open source culture and focused on public education can join part of this development process. It's definitely not exclusive to Scroll. PSE and 0x Park. And you can see a lot of amazing ZK researchers, as a part of this group that are expanding, whether it's new folding schemes or Nova, and trying to. But I think that the starting point is that there is a critical mass of projects and researchers and and engineers who subscribe to this way of thinking, and we're hoping we're one of the factors that makes this kind of philosophy more widespread amongst the wider ecosystem. So the idea that you have to build everything yourself or like hold it back from other people, keep it to yourself. I think that sort of mindset is slightly outdated, and we want it to be like outdated for the ZK world as a whole.
Tell me a little bit about the roadmap for Scroll. Like, I think we've done a really good job of catching us up to hear what's happened in the last year. And I think, you teased sort of what was coming and stuff like that. But tell us a little bit about the roadmap. Where is Scroll at? You said there's test nets. Is there a launch date? Are you going to be careful, actually, like announcing launch dates? Yeah. Tell me what's up.
Yeah, I can talk more on the technical roadmap, and Sandy can talk a little bit more about our ecosystem building. So on the technical side, I think currently our first priority is that we will launch mainnet soon. Like everyone's talking about it. But
okay. Soon. TM.
And so the first priority is that we want to build a complete and sound ZK EVM with a robust infrastructure, which means test of time and battle tested by all the community members. For example, our current testnet have been there are over 20 million transactions. It's a very large number, and over 1.5 blocks, and I think around 4 million addresses or something. It's a lot of people are actually playing with our testnet, so making that more robust, providing feedback, and also we already send our circuit to the auditor. So that's our first priority, building something complete. And then next step will be decentralized prover. So the point of decentralized prover is actually different from the traditional point of decentralization, which is censorship resistant. But building a decentralized prover net actually had two biggest purposes. One is that make your network more resilient, because prover needs a larger cost to run, right? People need to buy special hardware maybe. And if our prover goes down, then other people, there will be a bunch of backup who can still generate proof for you. And also it can incentivize people to build better and better hardware. If you are incentivized to run a prover, you are incentivized to make that more efficient to save your own money, right? It can make our network, this kind of finalization time on layer one, proof generation time becomes smaller. And then next step will be decentralized sequencer. So even if, as a layer two, even if we are running a centralized sequencer, you still have some way to avoid kind of censorship resistant. For example, you can enforce some transaction on layer one to enforce that execution on layer two. But it's still good to have decentralized sequencer because there are some problem of real-time censorship. For example, you send, you are going to be liquidated in 1 second, and then I reject you. And then I will include this transaction in 1 hour, which is still bad. So that's why you want to have this. And also some regulation, and also depends on your philosophy for how you capture MEV value and what this kind of value and mechanism, how that flow to different roles. I think that's the three biggest thing our roadmap on the technical side.
Yeah. With a very quick side question here, with a non-decentralized sequencer, does that sequencer collect all the MEV pretty much? Is it sort of an unfair advantage to that sequencer?
Yeah, it has this power to...
Maybe not all MEV, but a lot of it?
Yeah, it has power to kind of collect all the MEV fees. It depends on whether you believe this layer 2 will kind of operate
how you define
badly or not. But currently, I don't think any layer 2s are purposely leveraging this unique advantage to run MEV, to run some bad things. But there are also good MEVs arbitrage to kind of make balance your price and something like that. So, but I think eventually all the layer 2s are committed to decentralize in some sense. But it's just a very complicated design problem because you need to consider the value and how that flow. And there will be a lot more things happening, not only decentralized prover and sequencer, but a lot more things also happening in our roadmap, which will happen in parallel, including some efficient client implementation. For example, we will think about having multiple clients and having EVM parallelization, having that more efficient. And also we want to enhance our security through multi-prover. And also because Ethereum also evolving, we are part of this large ecosystem. We need to think about after they have, for example, in protocol PBS, which is short for proposer builder separation. If they have this infrastructure for context abstraction, which is 4337, and how we can engage and how we can maybe even overlap with this infrastructure. So that's a large problem, how we can coordinate changes with Ethereum layer 1. Because one important thing which differentiates from other layer 1s is that layer 2 can actually drive the changes of Ethereum layer 1 because we have the same goal to scale. So that's something we are also thinking, talking with the Ethereum ecosystem and talking with the thought leaders and how we can collaborate in a more open way and generate, generalize our research, post our research, and having more open discussion, and even maybe in the future form some standard for all layer 2s.
We're really excited by how much interest we've gathered in the permissionless testnet that we've been running for the last few months. As Ye said, we have more than 4 million unique wallet addresses on Goerli, which I think is a meaningful number, and it's very interesting, and that there's so much interest in the testnet, and also it gives us confidence that we're processing over 500,000 transactions on a daily basis. It means our code base it's been battle tested for about more than 4 months now with no critical failures, and there's still a ton of optimization to be done, but I think this is a very good basis, and it gives us the confidence to start talking to protocols and ecosystem partners and gearing up for a mainnet, as he has said. So on one part where we're trying really hard to onboard all of the tooling and infrastructure providers that are existing on Ethereum. So for them, the integration process should be no more than a day. There's no difference from deploying on Ethereum Layer 1 other than RPC. So it's a very quick process, and but there is a conversation to be had, and we're very actively having those conversations. On the other side, we've recently launched a permissionless kind of page for ecosystem projects to register themselves and so that they can find each other. Cool. And where any prep work is required to collaborate, they can use that as a forum. And within the first week, we've had over 100 projects kind of submit their information through this site. And we're in the process of thinking about how to organize it a little bit better, and to provide collaboration between various protocols and just bring a little bit of transparency. And on day one, I think users will be very interested in, what are the things that they could play with, what are the things they could interact with. And we're trying to build a very good kind of streamlined user experience so that traffic can be directed to whatever kind of, fun rides they want to play with, so to speak.
What's the name of that website, by the way?
So you can find it through I think the easiest way is to find the Build with Scroll handle on Twitter. Okay. It's tagged on the main Twitter account, and there's a form which you could kind of go into, and then it would be, I think it's linked to the main website. And I think over the last few months, we've been hosting a lot of kind of local hackathons and also local meetups and hacker houses.
Yeah, you guys were also at ZK Hack Lisbon.
Yes, we were.
And there was a few projects built on Squirrel. I think there was the ZK rollup. This is, I guess, an L2.
Yes,
L3, right?
Privacy L3. Yeah. I think using a lot of the Aztec tool stack, so that's very exciting. And cool. So I would say one thing that surprised me in this ecosystem building process is that there's a lot of organic ZK dApps and ZK implementations, and I think partly that's because of our team's DNA in ZK research, and so that's kind of through osmosis inspired a lot of ZK engineers to build things that are adjacent to Scroll. And also on the other side, we have a very active group of grassroots developers, and they're just hacking away and thinking of new things to be built. And there's almost like one or two games popping up every other week, and I try to stay on top of what's happening and playing with them. But there's a lot of interesting native things that are being built and preparing for our mainnet launch. And also I think that there's a team that's working really hard on kind of bringing on the existing more well-known protocols onto Scroll. The idea is that we want Ethereum users who are familiar with certain brands and certain protocols to find things that they're familiar with and they already know how to use. So there's a sense of familiarity, and then they can also find new adventures, like new protocols to play with and new games to interact with.
Do you see gaming as one of the key spaces that you want to sort of develop in terms of like just, do you want more games, more blockchain games on there? Is that a focus category?
In terms of product, we're building a generalized ZK EVM, so we don't have to choose. So we support everything. And the pros is that means, we offer something that's interoperable and something that can interact. If someone were to build a GameFi project on Scroll, it's more interoperable with the DeFi stack and vice versa. So I think that's the interesting thing. So we are seeing, games as a whole, it's easier to build in a silo and it has less dependencies. And I can see that being very popular amongst more isolated kind of devs or studios that are more organized around a single game type or processes. So I think that I can see a lot of games happening organically. As a platform, we're just focused on building exactly the same platform infrastructure experience as Ethereum Layer 1, which a lot of games have been known to thrive in.
Fair. Got it. Cool.
Maybe we could talk about hardware just very quickly. I think in terms of ecosystem building, I think we're quite unique in the sense that there are like more than 10 hardware companies building solutions for Scroll. And I think that's like one example of open source collaboration that's reaped or energized a whole adjacent industry.
Well, I want to say a big thank you to both of you for coming back on, to Ye to coming back on the show, Sandy for joining us on the show. It was really great to get a chance to find out what's been happening in Scroll this past year.
It's a pleasure to be here. Thanks for having us.
Yeah, thanks. Nice to meet you again, Anna.
Cool. And I want to say a big thank you to the podcast team, Henrik Jonas, who's editing this episode, Rachel and Tanya, and to our listeners, thanks for listening.